Okay, I think let's start because 20 minutes have been passed. So this is now the last CO or CLO. And the statement of CLO is categorize some advanced AI subdomains like NLP, ML, and DL. So in this CO, we will get mostly the introduction of these subdomains of artificial intelligence. NLP is the natural language processing, ML is the machine learning, and DL is the deep learning. So we will get mostly the introduction, and then we will get the understanding of at least one example or one model of these different subdomains. So starting with the NLP. So here is the definition. What is NLP? So it is a subfield of computer science and AI, no doubt. Before the introduction of machine learning and deep learning, there was only one big subdomain, that was the natural language processing, NLP. And now NLP is further divided, you can say, into machine learning and deep learning. And when this artificial intelligence, this domain was started, at that time, in the beginning, there was only two subcategories. Number one was the expert system. Then number two was the robotics. Expert system normally is a kind of software that you have to operate on that robot. So robot is a hardware, but what is the software for that hardware? That was the expert system in the beginning. But now, with the passage of time, you have different titles for different subdomains. So anyhow, NLP is the subfield of computer science and AI. And through this NLP, whatever the digital devices, either computer, tab, mobile phone, whatever. So through this NLP, these digital devices can recognize, understand, and generate text and speech. So text and voice data both. So through this NLP models or through these NLP algorithms, you can say a machine can recognize, understand, and generate text, and also can recognize, understand, and generate speech data by combining computational linguistics. Nowadays, that was not in the beginning, but nowadays, this computational linguistics is now becoming the identification of this NLP, because mostly in NLP, you normally deal the data of different languages, for example, Arabic, English, whatever. And if you are dealing human languages, then you have to, and then for each language, we know that there are some grammatical rules or something other like that. So that's why the area of linguistics come into it. Normally, in the area of linguistics, the expert who are in this area, they normally deals the theoretical knowledge of languages. It can be part of speech, it can be syntactic analysis, it can be semantic analysis, it can be grammatical analysis, it can be thematical analysis, and many more. So, in generally, the machines can recognize a language. If you are speaking, then the model can recognize and convert it into text. That is called recognition. Through this NLP, machines can recognize, understand. Normally, with the chatbots, if you are putting your questions, then chatbot is understanding and replying you according to your questions. So that is the word understand. And the generate text. Chat GPT is generating text. It's a big Chat GPT is a big application of NLP because it is with the language, data of languages. Anyhow, so now through this NLP, machines can recognize, understand, and generate text and speech by combining what? Computational linguistics, which means the knowledge of languages. And computational means then that knowledge of languages will have some computational models, okay? Some mathematical models. I don't have to say mathematical because mostly, for example, if you will go into the Arabic department, the linguists who are there, they only know theoretical linguistics, rule-based linguistics. They only know rule-based linguistics. That there are some rules defined in their books and they have to follow those rules. For example, I don't know, I can do a mistake because Arabic is not my language, but for example, I can say Arabic is a VSO language. VSO means verb first, then subject, then object. So this is one rule for Arabic. And then you will have many other rules, but this is just an example. Is this a correct example or not? Okay. And similarly, so in this area of NLP, you can do what? You can build models for the languages. You can build models for the data in these languages. So, but you can build these models by using what? You can use rules which are already defined, and you can use them, and you can make a program of those rules, and then it will be something called computational. And then, okay, you can also use statistical approaches, the theories which are available in statistics. You can apply them on the languages, and then you can get some useful use of those statistical theories. Uh, and then you can get something automatically from the data. So that is also the part of NLP. Machine learning is also the part of NLP. Machine learning is basically statistical approaches. In machine learning, you are performing or you are building some statistical models which enables you to automatically classify, extract, I can use many words, different things from the data. And similarly, deep learning. So deep learning is also a machine learning, but deep learning focuses only on the neural network and its variants. So mainly NLP is all about the data of different natural languages, the languages that we normally speak. So this is just a diagram that NLP is directly connected to computer science and then AI, and then it deals with the human languages. Okay, moving next. So from the previous slide, we have seen that what is rule-based. We have seen some terms, rule-based, statistical, and deep learning. Now we are giving some further information to these different terms. So rule-based NLP, I already explained, but let's see it again. So rule-based NLP was the first method in the NLP. You can say that. That's why it was the oldest. It is one of the oldest NLP methods. And in this method, you normally use predefined linguistic rules. I gave you the example of VSO for Arabic. Hmm? And then you know that there is pronouns, adjectives, and these kinds of different things. And these kinds of different things have further rules in it. And if you have to write a sentence, then you have to follow those rules. Then you have to follow those rules. So in rule-based NLP, you have to follow these predefined linguistic rules to analyze and process the text and speech data. Either the data is in text form or it is a voice data. You can use what? You have to use already defined linguistic rules to process them and to analyze them and to get something from them. So this is the field of rule-based NLP. Then statistical NLP or machine learning. Okay, we know that this is the area. This is the NLP in which we will use some statistical models. It is also called machine learning. What we will do in it, we will assign some probability value or we will assign some likelihood value to some element or the elements that are available in the data. I am using the word element. It can be anything, okay? It can be anything. So we have a text file or we have a voice data. What you want to identify from that data, I am saying it element, huh? So what you will do in it, you will calculate the likelihood, you will calculate the probability of those elements. And then I'm not saying training or anything. And then you will calculate probability of those things. And then the model will automatically be able to extract that information from that data, or it can classify those elements, which is classification, huh? Classify those elements in that data, or it can label label those elements if you will give some more data which has not labels, huh? Which has no any probability of value or whatever. It has not any labels. It does not have any classes. If you will give some test data like that, then it will automatically calculate the label for that data based on the data that you already, for which you already calculated the probability. Yeah. So that's why it can automatically label the elements of that data. Either that data is a text or voice data. So then this is called statistical NLP, or you can say the machine learning. But this is also basically it is NLP. And now you have this. Now this is not a new term, but before you can understand that in the beginning it was NLP. And then in this NLP you have NLP is, oh sorry, machine learning is the subdomain of NLP. But now it is a separate uh, entity and is popular also in one way. And then deep learning. So deep learning is also statistical. Deep learning NLP is also statistical, using statistical model. But the only difference is deep learning is an advanced model of machine learning, and deep learning is using what? Only neural network models. There is no any other. There is no any other model like naive Bayes or decision trees, or you can name it. All the other models are in machine learning. Neural network is also in the machine learning, but only the first small unit of neural network. If that neural network is containing many layers, you can say more than 3 layers, then it is lying in the category of deep learning. Anyhow, moving next. What are the applications of NLP? So question answering. You are doing some question in some language, Arabic, English, whatever, and then you are getting your reply, getting your response. So this is what this is questioning, answering. This is questioning, answering is an application of NLP. Spam detection. In your emails, you are detecting your spams, the emails that you don't want, huh? That is called spam. So, so that is also an application of NLP, but now people are saying it is the application of machine learning. Okay, no issue. Because it is everything is now mixed. Everything is now mixed. So email has the data in some language, huh? So then you will do what? Machine learning model, that is the part of NLP, and then you can detect spams. Okay. Sentiment analysis. Sentiment means it have this term sentiment has different senses, different meanings, but you can say all meanings will be close to each other. The concept is same. If I say sentiment is opinion or comment, okay. If I say sentiment is attitude, okay. Sentiment is behavior, about behavior of human behavior, human attitude, human behavior, or emotional, or human's emotional state. If I say this is sentiment, okay, this is sentiment. So sentiment analysis, why we use it? We use to analyze the attitude, behavior, and emotional state of humans in their data, not directly by looking at the faces of the humans. No, you have the data either in the form of text or either in the form of speech, and by analyzing that data, then you can analyze that what was the attitude of that person in that conversation, what was the behavior, rude behavior or normal behavior, what was its emotional state, happy, sad, or whatever. That's why these emojis are displayed, happy, sad, or whatever. What was its emotional state? If you want to detect that from the text data or voice data, that is called sentiment analysis. So these are some examples. Sentiments can be positive, negative, or neutral for a product. This is one example. On different websites, for example, Amazon, you are buying something and then people are giving their feedbacks, huh? Some feedbacks can be positive, some feedbacks can be negative, some feedbacks can be neutral. So this is also an example of sentiment analysis. Sentiment analysis about rating of that product. This is what those websites, they have these algorithms already there, and they are calculating the through that feedback, they are calculating the rating of those products. Similarly, a person can be happy, sad, angry, etc. for mood status. That's why this picture is displayed. And then machine translation. Translation. Tarjuma. Huh? Translation. You only have to think about not machine learning, only machine translation. So when you want to translate text or voice data or speech data of one language into another language, that is called machine language translation. One example of this Google is written is given here. And then spelling correction. Normally, when you are typing in MS Word or in some other word processing application, when you are typing, then you normally do some mistakes with respect to spellings of the words. Then there are applications which are running in parallel and which are correcting your spelling mistakes automatically. So this is the application of also NLP. And one example is given here in this picture. Speech recognition. I already said maybe 5, 6 minutes before. What is speech recognition? When you are speaking, and then your model is listening you and converting into text your voice, whatever I am saying, if that model is converting it into text, this is called speech recognition, because that model is recognizing my speech and then it is converting into text. So these applications, these speech recognition are available in MS Word. You can enable those modes and then you can speak, and that data will be written in the MS Word files. You may have the problems of accent, but when you will do the training in those applications, then it will be okay with the passage of time. So that is one example which is mentioned here. Chatbot. Okay, this is what you already know. There are many chatbots on many websites, so you can uh, chat with those bots. And this is one example mentioned here. Information extraction. So information extraction, this is a general word. There can be some systems through which you will do some query and it will return you information. This is also one thing. This is also one thing. And there can be also some systems in which you have unstructured or semi-structured documents. There is some database in which you have unstructured information. You are just putting the files in it. You are not arranging them or whatever, huh? Or you can have a semi-structured documents. Something is arranged, something is not. That is something called semi-structured. I'm using the general word arrange because at that moment I cannot say something which is the subject of information retrieval and you have many different terms in it. But anyhow, if I will use those terms, then you will not understand anything. So you can say that you have the raw data, unstructured or semi-structured documents, and then if you have some models which can extract structured information from that unstructured information. And here, one example is written unstructured web text. So this is the second sign of the zodiac is Taurus. This is one information placed somewhere in the document. And then you have strokes are the third most cause of the death in America today. This sentence is something lying in and some other document. Huh? Similarly, this one. And you can do some query and then you can have structured information like that. Sign of zodiac. What are the different signs? 1, 2, 3, Aries, Taurus, Gemini. And you can write all the, I don't know how many how many 12 or 12 or what? The stars, Aquarius or Taurus, Mizan, like that. 12? Okay, now I forgot. Okay. It was the topic of mine, maybe when I was a young boy, huh? But not anymore now. So, anyhow, most common cause of death in America. Okay, so if you will do this query, what are the most common cause of death in America? Then that system will give you this list by looking over all these documents. So from that, information extraction is like a search engine, huh? But you normally we call them information retrieval systems. Okay, that is a separate course. Normally we have this course information retrieval in computer science, but I'm not sure that you have this course in your degree. And then natural language understanding, NLU. So through this natural language understanding, we normally try to make machines. We normally try to make machines able to understand meaning of the, you can say, word, if you are giving example, meaning of the sentence or context of the sentence, what is before, what is after, huh? And intent of the sentence. If we have a sentence, and if you have some model built for the natural language understanding, this is the subdomain of NLP, okay? Or you can say this is a topic in NLP, natural language understanding. And through this topic, we can make some models, and then machines normally understand. If you will give them some sentences, then the machine will understand the meaning of the sentence. And if you are talking with the machine, or if you are giving a document to that machine, and machine is processing that document, and maybe the machine is at sentence number 10, then machine will understand what was before this sentence and what was after this sentence, and if different things are in that sentence are connecting to what previous concept and what next concept after that sentence. So that is called context. Yes.
Why this application is separate? Each application must understand that language activity.
Uh, for example, spam detection. Here, your objective is detection of emails which you don't want. Hmm? No doubt it is a small portion of language understanding, but here your model would be different. It is like a classification, spam or not spam. You will not consider anything other thing. You will not go into the details of language understanding. Maybe you will identify some keywords in the email. If those keywords you will find, you will declare them spam. You don't know. You will not go into the details of the whole sentences or words in those sentences. In this example of spam detection. But here you are going into detail. You are trying to get the meaning of each and every word in that sentence and what is the meaning of that sentence. You are going to get the things which were before and which were after the sentence, and the intent of human language. And if you have some sentence, what is the actual meaning of that sentence? Actual doesn't mean here the physical meaning of that sentence. No, what the human want to say in that sentence, in that sentence, that is called the intention. Intent, from the word intention. What is your intention? Because sometimes you use different sentences for conveying different uh, meanings. That would be not the literal meaning of the sentence. Oh. I can think of an example. If I am angry with you, being a teacher, if I am angry with you, and you are doing some work which I don't like, but if I say to you with the anger, okay, do it, then you understanding my intent is not to you that do it. My intent is to stop that, huh? To stop that work, huh? This is one example. This is one example that the sentence is different, do it, but the intent is not to do that. Not to do that. So I don't want to go into the details of these things. I can go. I can spend too much time. I am teacher. I am a talkative, huh? You can say. This is my duty to talk for hours and hours, for hours, huh? So anyhow, so in NLU, you can take this example that I would like to book a tea place, and then here you have a natural language understanding model. That model will have some kind of a, I will not use the database, but it is like that. You will have some word here with the sentences and some words here with the sentences, and you have a storage of different things. And then this model will compare, will match these words with those things. Here you have sentences, book, and you have different sentences in which you use the word book, or you use the synonym of these, of this word book here. Book is one word, reserve is one word, confirm is also one word. Confirm this seat for me, which means reserve. So you have some sentences like that in which you are, your intent is book. And if your intent is price, and here you have sentences in which price is used. And if your intent is cancel, then here are the sentences in which you are using the word cancel or synonyms. And similarly, you have different intents. And through that, after matching, it can be probability based. After matching it with these things, it is finally giving you the meaning of that sentence. Finally, giving you the meaning of that sentence. Okay. So just to concluding the applications of NLP, here you can see the applications. It can be machine translation, information retrieval, question answering, dialogue system in which two peoples are doing dialogue with each other, or you are doing a dialogue with the machine, that is chatbot. So these are those previous applications, mostly which are written here on the left hand side, generally applications. But what are the core technologies of this NLP? What are the core technologies of this NLP? For example, what is your core course? You can say algorithm is my core course, data structure is my core course, which is the main courses of computer science. Similarly, what are the core technologies of NLP? Here are language modeling. We have these languages. Arabic is a language. How you can build a model for that? Language modeling is one sub area, one area in NLP in which you can do some work in it. For example, on your mobile phones, you are writing a word and the next word is predicted, or the word is automatically predicted. How these things are going on? This is called language modeling. This is one application of language modeling. And then part of speech tagging. In your sentence, which word is noun, which word is adjective, which word is adverb, which verb is verb. This is what you are highlighting, the part of speech of those sentences or of those words. Identifying these different classes of words is called part of speech tagging. Then syntactic parsing. Syntactic. Syntax, from the word syntax. Do you know the syntax of Arabic? If you will ask me, I will say, shoya, shoya. Okay. I will say a little bit, huh? So, syntactic parsing. So, if you will ask this from some theoretical linguistic, he will say to you grammatical parsing. But you are a computer science person, so okay, then you can say syntactic parsing is something in which you normally deals the phrases, okay, in a sentence. Phrases in a sentence. Phrases in a sentence. For example, here, this NLP lies at the intersection of computational linguistics and machine learning. Then you can say, okay, NLP lies is a verb. At the intersection is one phrase. Of computational linguistics and machine learning is one phrase. That is noun phrase, And then this of is a proposition or preposition, What is the word for preposition? I don't know. Fil Arabi or fil Urdu, I don't know. In my own language, I don't know. Huh? Look at it, me. Huh? In my own language, I don't know what we call it. Preposition. I don't know. I I learned these things when I was studying in the school. After that, I don't know. Huh? This is in English, it is called preposition. Okay. This at this of is not preposition. This at is preposition. Okay. In at, these are the prepositions. Of is not. Of is possessive. Of is possessive means showing malkiyah. If I'm wrong, if I'm right, I don't know the word malkiyah. I have said it is okay or not. So, for example, of is showing malkiyah that this thing is connected with that. Okay. Anyhow, identifying phrases. This is one phrase. This is another phrase at the intersection or at the intersection, which is due to this proposition. It is preposition phrase. And there's this NLP containing only one word, but it is also a phrase that is noun phrase. I will give you the example. So syntactic parsing is about phrases, or you can say about grammar of the language. Okay. Or you can say grammar. Why I am saying grammar? Because if you will go to some theoretical linguist, he will say syntactic parsing is grammatical parsing. But being a computer scientist, we can say syntactic parsing is something related to phrases, phrases of the sentences. How in a sentence, if you have a parser, huh? You understand parser, huh? If you have a parser, and if you will give that sentence to that parser, how that parser will make phrases in that sentence. That is called syntactic parsing. Named entity recognition, how you identifying different names in a sentence or in a text. Those names can be the names of the person. Those names can be the names of the movies. Those names can be the names of the places, locations, etc., etc. This is called named entity recognition. Word sense disambiguation. Sense, here the word sense means meaning. The meaning of the words, how you will disambiguate them, how you will differentiate them with each other. Uh, in Arabic, you will have many words. Sometimes those words can give you other meaning when you are using in some sentence, and when you will use that word in some other sentence, that word can give you other meaning. Huh? It is true in all languages. But that word is only one. In my own language, I can give you many examples. If I think in Arabic, I think I can give you also many examples in Arabic, but then I have to take a pause for 1 minute or 2 minutes for thinking. So, but I have given you the idea. I have given you the idea. When you, the word is one, but it is giving meaning, other meaning here and another meaning here. So, being a human, you understand what is the meaning here and what is the meaning here. But the machine, for machine, how they will understand? How they will understand? So you have to build models for that. You have to build models for that. Through that, after that, the machine will understand that if that word will be used with this context, the meaning is that. If that word will be used with this context, the meaning is that. And when the machine will be able to differentiate between the meaning of these words, this is called word sense disambiguation. This is called word sense distribution. how the machine will differentiate sense of the words according to its use. Semantic role labeling. Semantic role labeling. Normally, when in computer science, when we normally say semantic and also with respect to parsing, and here the word is role in a sentence, you have one phrase, you have another phrase, another phrase. Semantically, what is the role of that phrase? Uh, I'm thinking some example in Arabic, but Arabic is not my language, so that's why it is take my processor is taking time. I don't want to give you example in English or some other language that is no use of for you. So I am thinking something in Arabic. Anyhow, identifying subject, object, or you can say identifying subject, direct object, indirect object in a sentence. This subject, object, or indirect object, these are semantic, these are the semantic labels in a sentence. So if some sentence is given to you, and if you can identify what is the subject of that sentence, then that is what you have identified the semantic role. One semantic role in that sentence. Similarly, if you have identified the object, file, mafool, something like that, huh? So if you identify a file, mafool, or maybe there should be some other word for indirect, mafool ale, or something like that, huh? For mafool be. Okay, so if you have something like that, then and if you identify the can if your model can identify these things from the sentence, then this area is this area is about. You have to identify subject, object, indirect object, maybe sometime modifiers, maybe sometimes adjectives, etc., etc. So this is called semantic uh, role labeling, and so on. So these are some core technologies which are lying in the NLP. And now you have also this definition for the NLP, that NLP lies at the intersection of computational linguistics and the machine learning. If you will combine machine learning and computational linguistics, then this is called NLP. Then this is called NLP. Here I have written, now we are going to start the pre-processing step for NLP, machine learning, and deep learning. So these steps now, which we are going to say step 1, step 2, 4, 6, 8. So these steps are common in NLP, ML, or DL. Because this ML and DL is the subtopic of NLP. So that's why it's common, huh? It's common for all pre-processing steps. So in future, if you will do some project in ML or DL or in NLP, you are dealing with the data, you have to do these processes. Not all, some of it. But here we are going to present some of the uh, pre-processing steps. Number one is sentence segmentation. Sentence segmentation. Segmentation means making something into pieces, huh? So sentence segmentation here means how you can, if you have a document, and if the in that document you have paragraphs and paragraphs, from those paragraphs how you can separate the sentences. This is what the segmentation means. For example, here, this is one paragraph given to you. Do the sentence segmentation of the following para. Okay, you know that in English, full stop somewhere is the thing through which you can identify that this is the end of the sentence. But sometimes this full stop used as the end of the abbreviation. Hmm? So you have to be very smart. So, but most of the time you can identify this from this mark, huh? So you can build a small program in which you can make this condition. Whenever you find this, separate that text from that up to this boundary, separate it in a new file and put the new line after it. And in this way, you can have all the sentences. So, and then another mark is coming here. So that's why if your segmenter, sentence segmenter, if you have a sentence segmenter, which is, you can say is an application for doing these things, it will separate sentences like that, huh? So one sentence is this, another sentence is this, another sentence is this. Three sentences somewhere in this the capital. Where is capital? Yeah, here there is another one. Based on these periods or full stops or dot, we can we can separate these sentences. This is called sentence segmentation. Step 2, word tokenization. If sentences or paragraphs given to you, you have to separate the words. Hmm? That is called here that is called word tokenization. That is called word tokenization. In NLP, uh, tokenization, and you can make in new definitions. Tokenization is something unique word separation. And when the word tokenization will come, it means you only have to separate words. If there is a repetition, no issue. But in tokenization, you don't have repetition. If one word you already separated, but anyhow, leave it for a moment. Leave it for a moment, because then I will mix this concept with other concept. So word tokenization here is, if you have sentence or paragraphs, break into words. So that is called word tokenization. For example, this sentence is given to you up to this end, and if you have built word tokenizer, it will do what? It will separate. This is one word, this is another 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 word, and you can see all the words here. Stemming. Step 3, stemming. Stemming is the word from stem. Hmm? From the word stem. What it means, if some you have the text either in the form of paragraphs or sentences or some words. So in stemming, you have to do what? You have to normalize the different forms of the word. Inflected words means one word which has different forms. For example, kataba, oktub, maktub, and different, huh? Kataba is same, but you have different forms, huh? So, and if you have one word which has different forms, that is called inflected word. That is called inflected word. And here in stemming, you have to do what? You have to normalize those inflected words into stem or root form. Root form, the short form. Yes.
We have some rules that if you add some points or some extras in the word, sorry, the whole meaning will be changed.
Yeah, that is not issue. Meaning is not the issue here. Yes, this is true for all languages, not only for English. For example, kataba, oktob, and both have different meaning. But that kaf, ta, and ba is same, huh? In both the words, but they have different meanings.
Um, and the word itself, and other word is normalization. So they have all different meanings. So how is stemming work?
You are saying that if I have words and if I will normalize it into root form or stem, then that root or stem will be totally different meaning.
The code is the same. They have different meanings.
Yes, okay.
So how the stemming would differentiate between? Like
It
for
will
example,
differentiate. It will differentiate. For example, for uktub kataba, stemming will give you the word root kataba only. So you have put the question before understanding this point which I am saying. Okay, what is stemming? Stemming, okay, it is a concept, and if you want to do or if you want to do stemming through some application, then that would be called a stemmer. And then that stemmer will do what? It will see different words and then the similar words, similar in shapes, but inflected forms, word with different forms. And then it will extract the stem from that. This application does not have any concern that what would be the meaning of that or what would be the meaning of that. We are not concerning with that. It will give us the stem or the root, nothing else. Meaning, we don't have any concern with the meaning. Okay, this is the answer of your question. You are asking about your meaning. What we do, you are asking that their meaning is different. How we deal that? We don't know. We don't need that. Okay, we are not concerning with the meaning. Yeah, we only want to get the stem or the root. So, in all languages, in all different languages, where you have inflected words, for example, here in English, intelligence, intelligent, and intelligently. These are the three different forms of something similar, something same word you can say. Huh? These are the three different forms of something, one word you can say. So, and these are called inflected forms of something. Of what is that something? We are calling it the stem or the root, and we want to find that. So, stemming will do what? It will normalize the different forms of the words into the root form or the stem. So, stemming will produce what? It will produce stem or it will produce the root of the word. Sometime that stem or root can have meaning or sometime cannot. Sometime cannot. But it is not the objective of the stemmer or stemming that you will have the root or the stem and it is must that that root will have the meaning. No, that is not required. For stemming, if you are getting root of the inflected words, if that root has the meaning, okay, good. If not, no issue. No issue. For example, here, intelligence, intelligent, and intelligently, three different words. And here, if you apply, if the stemmer will give you the root or the stem intelligent, which is not a word, huh? Which has not any meaning. Intelligent, because intelligent is a common maybe in all. Huh? So stammer is normally giving you something the shortest but common in all different forms of the word, and it has no any concern with the meaning. But sometime it can give you some stem which has the meaning. It depends. It is random, huh? It depends on the words. So intelligent, here the stammer is giving us intelligent, which does not have any meaning. This is called stemming. This is called stemming. Now, step four, lemmatization. Here, it is very much similar to stemming, but now the stem or the root that you will get must have the meaning. Okay, must have the meaning. So, must have the meaning. For example, intelligence, intelligent, and intelligently. If this is again the same example, then lemmatization will give you intelligent, not intelligent. Even this is not common, huh? This is not intelligent, is not common in all, but it is giving you intelligent, the shortest among all. And now this has the meaning. Normally in linguistics, yes. It depends on your example. If you are considering the meaning of the words also in your application, then you will go with the lemmatization. And if you are not concerning with the meaning, then you will go with the stemming. Mostly in machine learning, in mostly applications, you are performing stemming, not lemmatization. But if some NLP guy will work, it will go with the what? With the lemmatization, because it has the meaning. Step five, filtering stop words. Step five, filtering stop words. So filtering mean removing, and stop words is a term in NLP or linguistics the people normally use to represent some words. And what are the stop words in English? For example, here you will see it can be any, but normally for example, the article, it is a stop word in English. A, a, it is also a stop word in English. So, as a definition of stop words, you can see that these are frequent words. These are the words which will occur often, huh? But it does not have any contribution in the sentence. So, for example, here this example is not okay, but anyhow, the people who are purely computer science people, they don't know anything about linguistics, and the people who are only the experts in machine learning, maybe for them this example is okay. But the people who are related to NLP means that they have the knowledge of machine learning, deep learning, and also the knowledge of linguistics. Okay. So they will not be happy with this example. But anyhow, what it is saying that in your text, or so you have to highlight what are the frequent words. For example, is, and, the, so these words will be very much frequent in the text. And these words, okay, the and is okay, that they will not contribute too much in text, but is and is contributing. But anyhow, leave it. Ignore this and consider all these words stop words. Okay. So you have to highlight frequent words in your sentences. And then only those, and then you have to consider only those which are not contributing too much with respect to your model, with respect to your application. Then those words would be the stop words. So it means, so that's why you will see in the literature that if you will have some article related to machine learning, and many people are first they are introducing that these are my stop words which I removed, which I filtered out from the text data. Why we are doing that? So that the model don't have to process them, and then the model will be faster. Okay, this is the only purpose, huh? This is the only purpose for lemmatization, also stemming, so that your model will be faster. So and these words you have to filtered out before any statistical analysis of your model. This is the first, this is the pre-processing step. That's why all these steps, not this one, all these steps which we are studying here, this is the pre-process, means this is the first step that you have to do before building your model. So for example, he is a good boy, so is and a remove them because it is not needed, and you are calling that is also your stop word, is also your stop word, so remove them. Now step 6, dependency parsing. Dependency parsing, for example, in a sentence you have words, and then how the words are related to each other, how the words are dependent to each other. This is, and highlighting these things is called dependency parsing. Highlighting these relations is called dependency parsing. For example, here, this is just a reference, leave it, from where this sentence is taken. And the sentence is economic news had little effect on financial markets. Economic news, you can understand that this economic news is composite word, is a compound word, is a combined word. Huh? Two words making one word, you can say. So economic news. So then news is what? What is the part of C? It is a noun. And the label for that noun is NN in this article. In this article, okay. You don't have to worry why it is NN, why it is JJ, why it is VB. Leave it. That is not your concern. Just understand that this is noun. So news is what? A noun. And what is the adjective? And this economic is the adjective of this news, huh? Ism sifat, huh? So this is the adjective of this news. So that's why this you are seeing this arrow here. That noun has the adjective economic, and we are representing that adjective with JJ. Okay, leave it. That is not your issue. Why he used JJ? Leave it. People can make their own tag set and they can use their tags. That is not an issue. So this news, so now I am representing that relation, that this news has an adjective with this arrow. With this arrow, with this arrow, you are representing this relation, huh? This relation that this noun has this thing, has this thing. And in English, if you have anything like that, you normally call it modifier. So then you can call it noun has the modifier adjective. Okay, in English. In English, you can, how you can say this thing? Noun has a modifier because noun has that sifat. So that sifat is modifying the concept further. Huh? So that noun has the modifier, and here we are representing it n modifier, which means noun modifier. Okay. And then economic news had little effect on financial markets. So then had is the verb. and has had. So this is the third form, you can say, had. So this is the verb, and you can represent the third form of the verb with VBD. You can write V only. Okay, you don't have to worry. You can write only V here. But here VBD means third form of the verb according to this article. According, and this is the name of that person, Joachim. So, so this is the verb. And then, okay, then if you will think, economic news had little effect on what? On this thing, financial markets. So little effect is again compound word, huh? Combined word. Effect is what? Effect is a noun, and little is its adjective. So again, similar concept like here, noun modifier. Noun has the modifier adjective, huh? Okay, now this is done. Now this is done. And now think over it. Financial markets. So markets is noun again, plural. That's why S is here. NNS, because NNS is a tag here in this article. You don't have to worry. You can simply write N. Huh? So markets, and this is the adjective of that market. So that's why the same concept, noun modifier. Okay, this is done. So you have shown this relation also. Now this sentence has further relation in it. For example, this is a preposition. In something, in something. Huh? Oh, sorry, on. I was reading that in. So in the sentence on, huh? And in is a tag for the preposition. In is a tag for the preposition here. And on something. The conceptually, this is thing, something on something. And this is that thing which is lying on that thing. So then how, so first, this is the tag for preposition. And then you are saying that this this thing on this thing. So here you are saying that this thing is lying on. So this noun modifier of this preposition. And then similarly, this thing lying on this thing. So this is, for example, if it is a table, this thing is lying on this. So that's why you are showing that this is one thing, huh? And the major thing in it is a noun. It is a noun phrase. And then you are saying that this thing is lying on this preposition due to that on, this thing on that thing. And here the major thing is market. This is the modifier. Modifier in sentences is not the main thing. That modifier is a modifier to which entity? That entity is the main thing, okay? So this is also a noun phrase, this is also a noun phrase. And this thing is effect, and the word on is effect. So that's why the arrow is in that side. Effect on which? On this. That's why arrow is on the market. Effect on market. So this, due to this preposition, you have these arrows. And now come to this verb. Come to this verb. Verb also has, you can say, subject, object kind of thing, that concept. Semantics. So that's why here, economic news, this is something. Okay, noun is, if you will make it a phrase, then it will become noun phrase. And this news is the main thing in it. And then you are saying this is the subject of this verb. Subject of this verb. Subject of this verb. And what is the object? What is the object of this verb? This effect is the object of this verb. And then, okay, PU, that is the end, and then this effect is ending here, okay? So generally, you don't have to do dependency parsing, but this tree is, and what is the root for this whole parsing? This is the root. In dependency parsing, you have the verb is verb, the main verb of the sentence is always the root in dependency parsing. This is something you have to keep it in your mind. In dependency parsing, so you can say this is a kind of some tree, this is a kind of a tree which has the root verb. In dependency parsing, you have to focus on the verb, and then you have to identify subject, objects, all, and also you have to think about the phrases, and you have to make these arrows. These arrows are showing relationship between the words, and if you are showing all these relationship between the word, this is called dependency parsing. This is called dependency parsing. This is one type of parsing. There are many other different types of parsing. You will see some of which will come next, which is called syntactic parsing, or phrase parsing, or constituency parsing. Same names, same three different names of one thing, but you will see them. Step 7, part of speech tags. So, what I was saying, you don't have to think, you don't have to worry how I can draw these trees. Leave it. When you will do your PhD, then you will go into the details of that example. Here, you only getting idea how we are representing these relationships and how we are representing these words with different words. This JJ, this NN, this VBD, which you are giving here, you are giving these words the tag, and that tag is called part of speech tags. These all tags, okay? These all tags are called what? Part of speech tags, which is the step 7. Part of speech tag is what? Looking into the sentences and then classifying the part of speech class of the word. If you are saying this is the verb, you are saying the part of speech class of that word. Part of speech class of that. If you are saying that this word is adjective, you are saying the part of speech class of that word. And this part of speech class or part of speech, if somebody will ask what are the part of speech classes of the word, then you will say it is many: noun, adjective, verb, adverb. You can go on prepositions. You can say like that. And these all are the classes of the words. Example: Google on the internet. Google on the internet. So now if you have to give tag, you will say internet is a noun, the is article. Hmm? The is article, on is what? Preposition. Google is what? Somebody can say that it is the name of the Google, so it will give it noun. It can give this word that the tag noun, huh? But that is wrong. So Google on the internet means search on the internet. And then this Google is coming here as a verb. So verb is a proper part of speech class of this word. This is called part of speech tagging. For example, if you will give it V, preposition P, okay, article A, internet noun. Now this is called part of speech, huh? And you have given your own tags. Step 8, named entity recognition. So named entity recognition. So you have to identify. So you have the data in the text form, paragraphs or sentences, whatever. You have to identify entity from that sentences or data, which is about only the names. So from the text, you can identify names, which can be the names of the person, names of the movies, names of an organization, name of any location, name of any other thing. So you only have to identify names. That is called named entity recognition. You are recognizing these names from that text and then displaying. For example, here you have the example Steve Jobs introduced iPhone at the Mac World Conference in San Francisco. So if you have to identify names, only the names of the person, movie names, organizations, or locations, then from this sentence, Steve Jobs, you know it is the name of the person. Introduced iPhone, this is the name of something. At the Macworld conference, this is the name of the conference. So according to this definition, I am looking at only four things, huh? And then San Francisco, California, okay, then this is the location. And then if you are a model, if you are that software model, then you are giving me these two names finally. That one person, one is the name of the person, other is the name of the location. This is called named entity recognition. And if you will see this title somewhere in the articles, then you don't have to worry. This is what it means. Step 9, chunking. So, chunking, breaking a sentence into phrases, that is easy. Breaking a sentence into phrases. And you know what is phrase? You can build a noun phrase, you can build a verb phrase, you can build a adverb phrase, you can build a adjective phrase or whatever. For example, here, if the word is the little yellow dog barked at the cat. If this is the word, the little yellow dog barked at the cat. So barked is a verb, you know that. So the little yellow dog. So dog is yellow and also little, and these also attached. This is one phrase. This is one phrase which is noun phrase, huh? Because this dog is important. This dog is the main word which is noun. So due to this is called head word. And the other words are called dependent words. So due to that head word, this phrase is noun phrase. Barked is verb, and then at the cat. The cat is again noun phrase. This the cat is what? Noun phrase NP. And then due to this this due to this at is a preposition, then it will become what? PP. If I will make this tree, then what will happen? And then due to this bark, okay, then it will give me VP verb phrase. Hmm? And then here I will make this whole ANP. And then I will make a S and I will attach this VP to it and I will attach this NP to it. The complete tree for that sentence. And here, this NP, this PP, this VP, the phrases I made, this is called chunks. These are called chunks. But this is a very much detailed tree. You don't have to go into it. Here, take the simple that the little yellow dog, this is one chunk, which is called NP. The cat, this is another chunk, the NP. And here the at is displayed separate, but it should not be. Huh? It should be under it because at the anyhow. And this barked is also because we are talking about chunking. So here in this picture, he's making four chunks of this sentence. This is one chunk, this is another chunk, and then this, and then this. And these two are major chunks, and these are not chunks in it, but anyhow, you can say it is also the chunks. But these are not phrases, huh? So, according to this example, according to this example, 1, 2, 3, and 4, four chunks are here for this sentence. But if you will go with my example, I don't know, maybe so this is one chunk, and then another chunk, two, and then another three, and then yes, four chunks. That was a different annotation, that was a different. So chunking is about what? Breaking sentences into phrases. I am stopping here, and then I will start. This is now the new topic. I will start it. I want to take a 10 minutes break because the next lecture is starting at 10. Okay. So that's why I am stopping. That is the reason. 7020? Hmm? What was the section? 20. 270. Yes. This is the right one. Okay.